Thanks for showing up bright and early for a session of the day to talk about terrible code and how to deal with it, legacy code, and building microservices in an environment where you're not greenfield. All right. So I'm David Julia, Associate Director for Pivotal Labs Chicago, and we deal with a lot of legacy code all the time. Microservices architecture is meant to help you go very, very fast, but there are certain concerns that you need to take into account when you're building in a legacy environment and not greenfield. Now, microservices are great when you're existing in an environment where services are cheap and fast to deploy and you can change them independently. That's an amazing end state, but you can't always start there. One of the tools in our toolbox we're going to talk about today is how do we leverage Spring Boot to build microservices in a legacy environment, in an environment where we can't just go fast from the beginning. When I'm talking about a legacy environment, I'm talking about an environment where many of your systems that you're dealing with are hard to change. Maybe they're in dire need of replacement, and you actually have a business case for changing them or replacing them. You need to add new features. You need to get off of a third-party platform. There's a real business case for changing them. You can't just leave them and let them run. So this talk is really for developers. I want to show you how to get to microservices when you're starting with this big ball of mud. I want to talk through a couple things that are very important to keep in the back of your head when you're approaching the problem of introducing microservices in a legacy environment. One is lean heavily on domain-driven design. And as much as that's often just good advice in general, in a legacy environment, it's really easy to get caught up in the old way of doing things, in your old systems domain models. Don't do that. Try to approach things with fresh eyes, model the business processes that are today's business processes, not the processes that came 10 years before when your existing systems were written. Very important is not to start just spitting out microservices left and right. You need to evolve towards microservices. This is especially important in a legacy environment where you don't quite understand how your new domain is going to map to your existing legacy services. And this is a phenomenal website that I can point you to, appcontinuum.io, that talks about this in depth, how you can go from unstructured code towards an application with some shared libraries spit out as compile time jars, and then eventually to shared libraries and shared services, microservices. So the question becomes then, all right, we understand we shouldn't tie ourselves to our old domain. We want to model new services. We want to evolve and get there. How do I do that safely? Kent Beck, guy who was the originator of extreme programming, a lot of the practices that we use every day at Pivotal Labs, has a phenomenal concept, succession, which is, apologies for the tiny text there, but it's the art of taking a single conceptual change, breaking it into safe steps, ordering those steps so that you can optimize safety, feedback, and efficiency. So let's talk about a few succession patterns. One pattern that is actually quite popular, it was popularized by Martin Fowler, who documented this, is called a strangler application. So the whole idea is that you want to build a new application and start migrating behavior into that application gradually over time until you've strangled off the legacy system. So you're no longer reliant on the legacy system. You're starting to point all of your new code to this new, beautiful system. One other concept to keep in mind here is in doing this, when you're writing your strangler applications, you're going to need to understand what your existing behavior is. You need to characterize the behavior of your system before you can start moving bits and pieces around and have any confidence that you're doing so without breaking everything. Michael Feathers, in his amazing book, Working Effectively with Legacy Code, introduces the concept of tests as a vice, locking down existing behavior. We'll revisit that in a bit. Let's go through a bit of an example here. So let's say we're a large fast food restaurant chain and we want to write a mobile app. And we want to replace our rewards points vendor with our own in-house system. So every time you get 10 burgers, I give you a free burger. You can earn different amounts of points for ordering different things. And we used to pay a bunch of money to this vendor, and their platform kind of sucks. We want to get off of it. The whole motivation here is let's cut cost and introduce a mobile app where we're actually showing people their rewards points. Hopefully then they'll come back to us and eat more burgers. And then that'll set us up to add new features to our entire rewards points platform. So the logical first place to start is viewing your current rewards points balance on iOS. So let's take a look at our systems here. We have a legacy point of sale system written in some old crufty nasty Java. We have a legacy web portal, which is some unholy combo of PHP and Perl and God knows what else. Where do we start? I mean, they're all talking to the same database. That's a little scary too, but common. Let's take a little closer of a look at our legacy ball of mud POS system, or at least a subset thereof. Holy crap. I think I see some bidirectional dependencies. Transaction history depends on receipt printer, which depends on payment processor, payment service, and we got a customer over there. I've highlighted in bold all of the things that mention the word point, and they're kind of all over the place. God, what's up with that? Although I do see something that's interesting here. There's a get points balance by date in transaction history. It kind of looks like maybe every customer has one. We can dive into that in a second here. So the behavior we need, here's our plan. We're going to identify the behavior we need. We're going to move behavior to a new class, a tested class where we've characterized the behavior we care about. And then eventually we're going to extract components, and eventually we're going to get to some services. So it seems like that transaction history class has some behavior we want. We've identified a reasonable place to start. Let's look at how we can sprout off a new class. So again, referencing Working Effectively with Legacy Code, phenomenal book, sprouting is this idea of extracting new behavior to a new method or a class, often because you couldn't get the thing under test in the first place. You want to change it. You want to deploy it separately. You need to break dependencies and start a new class. And that's what we've done here. So highlighted there is our new reward points service. And we optionally can change that transaction history class to use our new reward points service as we move behavior in there. Depends on how conservative you're feeling. All right, we moved behavior into that class, all the while getting it under test, which not a trivial operation, but there's a lot of good stuff written about that, so I'm not going to go into the details of how you go about that mechanically. But let's say you very carefully, very methodically got that behavior into a new class. Okay, well, now the logical next step here, since we want microservices, we want to be able to call into this reward points thing from our mobile API gateway eventually, we're going to pull out a jar. Instead of deploying everything into that legacy applications jar, we're going to split off a com fast food inc. rewards points jar, and we're going to put that rewards points service in there. Then we're going to add a dependency to that new jar into our legacy application. Now, this operation isn't as trivial as that tiny little arrow makes it look. One does not simply extract a jar. It takes time. You need to break dependencies. Not represented here is probably about 100 data access objects, a bunch of dependencies on various serialization libraries, God knows what else. All right, well, that was all good and well, but how do I know I didn't just break everything? Well, going back to that original slide, did you guys remember that I had that crazy legacy PHP Perl hybrid weird web portal? Well, funny enough, the business actually says, no, we trust that thing. That thing gives us the right answers. It's really ugly, but we've had it around for 30 years. So let's make sure that we match the rewards points balances that are from that website. Well, great, but that site doesn't really have an API. It is a test oracle, so one approach would be to record any deltas between the reward point balances that we're showing in our new component when I call my new method, and compare that to what the website would have shown. So how am I going to go about testing that reward points component? Well, one approach, which is not always the approach to take, but one approach is consult your oracle. Invoke your reward points component, scrape that legacy web portal for some amount of time. It's a bit kludgy, but you want to do this until you're confident that you're seeing a low enough rate of deltas between those two components that you feel comfortable just saying, all right, now we can use this rewards points component. So let's say we do like what we're seeing. We're not seeing many deltas. Right now you're probably saying, okay, that diff thing won't work for me. I have mutating operations and I have a bunch of different stuff that just totally doesn't apply. Just meant to be one example of getting a little bit creative of applying that principle of succession. So you're going to have to use very critical thinking skills when you're approaching your legacy systems and how to go about making these changes safely. But you can adjust to your risk profile as well. So maybe you don't need to go ahead and build this crazy diffing thing. Maybe you're okay with the risk of mismatching. It totally depends on your business application and your business partner's appetite for risk there. All right, well, let's say that we logged all our deltas, we're feeling good. Let's extract a service. But first, a note of caution. Especially in a legacy environment, extracting a new service too early can actually be very costly. If you didn't quite get that domain mapping between your new domain and your legacy domain correct, and you want to churn on that interface, you want to change the interface to your new component, it's much, much easier to do that when you're in memory, when you're in process as a jar, and you're not maintaining a client and a remote server. So change things in one place where possible, live with that component until you really need to break that out into a service. Well, let's say we do. We really want a separate service. We really want that rewards points mobile application. Okay, so we're going to extract a service, implement a remote facade in our legacy application that calls into our new service. So we're maintaining the existing behavior. And then we're going to point our mobile applications API gateway to that new service. And then we have our iOS app. So what does that look like? All right. Well, we have a new service in a jar. That's our remote facade. It's going to talk over HTTP to a boot application that has what used to be our reward points component as a dependency to the left there. Now we still have two things talking to the database, the same database, but we've carved off some of the behavior. We're starting to strangle off the behavior of our original legacy application and put it into a new greenfield application. And so finally, the last step is to add our mobile API gateway and iOS app. There we go. We have our mobile API gateway, another separately deployed boot app, talking to our reward points boot app over HTTP. That's pretty cool. That's where we wanted to be. So what was that? Well, we started with a big ball of mud. We identified and extracted behavior into new classes. We packaged those classes as a jar, beat ourselves up, beat our head on the keyboard for a while, breaking dependencies, got that thing into a new jar, safely gave ourselves confidence that we were exhibiting the correct behavior and matched our other legacy system. And then we created a new service, pointed an iOS application at that, and could reuse that for 10 more applications if we wanted to. We did that all very safely and with high confidence. Now, there are a number of other steps that we could take. We could continue to move more reward-specific behavior to our service. We could continue to refactor our web GUI to use our new service. There are a lot of directions you could go. And the path that I showed you to do this was just one such path. You could imagine a lower risk profile where I just copied behavior into a new component and didn't change my legacy application until I had beaten that thing up in production for a little bit or gone through a lengthy QA cycle. It really depends on your risk profile and your ability to find seams at which you can test the new behavior. So that is what I had, and I wanted to leave some time for questions. I also have a bunch of appendices that I will point people to for all of the books that I referenced, and a phenomenal precursor to this talk, which is Mike Gayhard's talk on microservices around when to split out components, how to go about thinking of microservices, and then, of course, working effectively with legacy code. So, questions? Yeah.
Yes, please. When you mentioned next step, I think one more bullet very important, because your legacy application is a live thing, and you continue to maintain it.
Yes.
So maintenance of your new service will become very expensive also.
Yeah.
So you creating new services, you have to maintain them for some time, which is probably very costly also.
Yeah, absolutely. I mean, the more you can refactor to use that one single point, the better. Sometimes it's just really hard when you're dealing with something like munged together, half of it's PHP, half of it's Perl, and it's interpolated, and you have no idea what's going on. Maybe the long-term vision is to rewrite that web portal so you live in that awkward space for a little bit and decide you are going to pay that high cost to maintain two things. It just comes down to long-term roadmap and where you are in that journey towards the new services.
In the example that you showed,
Yeah.
where you had the API gateway,
Mm-hmm.
would that be something like an edge service implemented with Zool or something like that?
Could be. Yeah, if there's more custom logic or calling out to different things, could be a normal boot app, could be Zool. Yeah.
But it was still hitting the same database.
Yes.
So doesn't that defeat the purpose? Aren't you supposed to have your own single store?
Yeah, so eventually,
Put up an API and
yeah. So eventually you would definitely want to ETL into a new database and have your microservice own that database. That would probably be the next succession. I actually had an example like that in the talk and chopped it. Yeah. Yeah.
Right into that. Can you go back to your design diagram for a second?
Yeah, which one?
The one where you kind of showed the system that farther. There.
This guy? Okay.
So what would you do get a case, so you have transaction history, order, payment. Maybe those three systems all touch a common database.
Mm-hmm.
Table, say.
Yeah.
Is it supposed to be like one
I mean, ideally, your component and the bounded context that that component represents does own its own data store. And it might take a while to get there, though. You might actually have to break apart tables even. And then you do get into this, part of the reason why I say wait to break services out until you've lived with them for a little bit is when you're talking about especially breaking data dependencies and breaking tables apart. If you're just sort of doing that, guessing that you have the right idea of your domain model, that can be a really, really expensive mistake to make. So I tend to wait for a little bit and eventually migrate my data, break data apart, ETL things.
So you have like, let's say, teacher and student.
Yeah.
Those are two different objects.
Yeah.
Each other on data store. But you're going to need a student and teacher association table.
Mhm.
Right? Where would that live?
I mean, it depends, right? So it depends on, in your domain, if those things are very, very intimately associated, maybe they actually belong in the same component or the same microservice. But if not, then it's kind of up to the client code to do that join. So the API gateway would then have to do that join. And in some applications, that makes sense. In others, it really, really doesn't. And I've seen that bite people before, where they all of a sudden split things up so fine-grained that you're like, man, I'm just paying a bunch of cost for all these remote service calls. I'm not actually codifying my domain and the actual operations that happen here. I just am putting things into extremely decoupled services, and now I have a whole other problem on my hands. Which one? Yeah, the remote one is probably this one? Yeah.
So why do you need that remote service?
Why do I need the jar?
Yeah.
So
So we are not exposing that. So this is we are only exposing the REST endpoint API, right? So we are not exposing any interfaces to the chat, right?
yeah, sometimes it's nice to break out that client jar and reuse it across a couple different microservices. It's not strictly necessary. It could have just been inline in that legacy application. The one reason why I do like breaking out the jar, though, is what I alluded to earlier when I was talking about breaking dependencies and how hard that can be. It's really nice sometimes to give yourself small boxes to play in. So I often do create a new component for something as small as a client or a service. And then I have a very small curated list of dependencies that thing pulls in. And so I'm making sure that I'm not repeating the mistakes of that big legacy app that had just everything everywhere, and it was really hard to break things out.
Just a follow-up to that question.
Yeah,
This is the same approach that I took in my organization as well.
nice.
The overall, like migrating from legacy, I wouldn't call our services still as microservices, but more like microservices. Kind of exact similar approach. I'm happy to see like, okay, that approach is something that you're also implementing here. On the same exact point regarding the remote jars.
Yeah.
With my architects, I get into like a more philosophical argument on when you want to promote this as a microservice, is it right for us to expose a remote service jar?
Yeah.
My argument is like we're exposing the contract by giving the interface and the actual objects that the interface accepts, which is similar to like in the SOAP world, you give a business as a contract.
Yeah, I go back and forth on that too. So the question was, when do you actually expose that remote client as a jar and let people use it? I totally go back and forth on that too, because there's a cost to reusing that code. Now you're coupling multiple different services to that same jar. And depending on how frequently that jar has to change, how frequently that client interface has to change, sometimes you get into situations where you don't actually take advantage of the extensibility of REST. So I can add fields all the time with REST, and they might or might not be required. But in a Java interface, unless I always have to add a new parameter or add some new field somewhere. And so I end up churning on that dependency more. So I don't know that that's an answer, but those are the concerns that I try to balance when I'm thinking of those things.
Also, we did also with the client jar, and they had a problem of who owns this client for demand.
Yeah.
The provider has to write the client, or who are consuming, they have to write the client. That's how it is.
Just one
Yeah.
difference here. Not sure whether you're recommending that or not. It's not the actual client implementation. It's the interface. What you're looking at.
I think that would have some logic to call the REST API, right?
Yeah. I mean, there's definitely, it goes back to a matter of choice and a matter of who's going to own and update the dependency. Are you providing a jar as your first class interface to this service, or are you providing a REST interface as your first class interface? And which is the one you're going to document, maintain, and be comfortable with the amount that you have to change? Yeah.
So, again, you demonstrated an example with PHP and all that stuff.
Mm-hmm.
So, can you talk about, if we have done anything with the mainframe, a lot of legacy code in the mainframe to work.
Mm-hmm.
So, in that context, can you tell us, if there's something, again, applications are pretty huge. So, what are the performance implications that there were, like when you transform the mainframe application, and what are the pros and cons, and how do you?
Performance implications of doing this kind of transformation and extraction.
Clearly, with the nearness of COBOL, with the DB2, you have solid performance.
Yeah.
But you're adding layers here.
Yeah, and I mean, sometimes it's always a case-by-case basis. And a lot of the time when you have legacy data sources, legacy mainframe, dumping a bunch of stuff into a DB2 database, you end up introducing an intermediate caching layer like an in-memory cache, like a Gemfire or something like that, just so that you get the similar performance without necessarily having to still have a monolithic application.
How do these, like things that you have, like all the framework of Spring, how does it actually work on a mainframe? And can you run it on a mainframe?
I've never tried to. Yeah.
What happens if you just take that mobile app and hit the rewards point service?
You could, but now you're coupling your mobile application to your one microservice, and you don't have the ability to do aggregation and transformation.
That can I have if I have another service next to it?
You could.
And whoever needs to access it. Now I'm occupied, no reason, right? I'm going from the mobile app to the rewards app.
Yeah. So anytime you introduce a layer or a REST service, there's always a performance penalty, but often it's not that much, especially when you're in network. All right. If you guys have any other questions, I'll be hanging out outside. Thanks.